Hello everybody and welcome back. We're going to continue with our flat asteroids programming. We've been working on the physics engine right now. Just a reminder, we do have all of the code available through GitHub. We have a repository here called Flat Asteroids. So if you search for that, you should not only have the flat library code listed here, but also the actual game Flat Asteroids code here as well. Freely available to do whatever you want with. Go ahead and feel free to download it. Let's go back to our game class. So inside our game class today, I want to talk about, we are working on the physics engine, but I want to talk about optimizing the nested for loop that we have. Inside of our update function, we have down here a nested for loop, which is where we are going to do all of our physics work. The interesting thing is, the way we've done this, we loop through every entity and then again loop through every entity and compare every entity to every other entity. And we negated that a little bit by doing this I equals j comparison. So we compare the indices, and if they're the same, we don't test them because they're the same entity, so we don't need to do that. But there is a more efficient way for us to write this for loop that'll make it so we only test every entity against every other entity once. All right, so let's just say we have an entity list that has 4 entities in it. The way we're doing it now, this is the way it would look. And I'm just going to make this into a grid so we can get an idea of what this is, what's actually happening here. So on the first top for loop, we're going to start with entity 0, and then we're going to loop through every other entity, comparing it to this. So we're going to loop through entity 0, 1, 2, and 3. All right, then we're going to move on to the next one, and we're going to compare this one. Then we move to the next one, and we're going to compare index number 2, and the same thing with the last one, 0, 1, 2, and 3. Now you can even see how we did do a little bit of an optimization when we compared index I to j to make sure we're not comparing the same index. Was it actually eliminated these comparisons where we're comparing 0 to 0, right? So this one would actually be eliminated. And then we're comparing 1 to 1, so this one would be eliminated. And same thing here. Even though we're not actually doing this comparison, it is part of the loop. And so we're looping this many times this many times. So it's 4 objects this way and 4 objects this way. We end up with a loop that is 16 times. And now, not only do we compare objects that are the same, but we do comparisons twice. For example, I'm comparing 0 to 1 right here, but then again over here I'm comparing 0 and 1 again. All right, and I'm comparing 0 and 2 right here, and then back over here I'm comparing 0 and 2 again, and then I'm comparing 0 and 3 over here, and then I'm comparing 0 and 3 again. There's a lot of overlap. We don't need to do these comparisons so many times. So is there a better way we can write this loop? And the way I want to write it looks something like this. The top loop is actually going to do index 0, 1, and 2. 3, I'm going to draw here, is not actually even going to happen. And we'll draw y in just a second. Let's go ahead and draw the new grid. First of all, we're only looping 3 times instead of 4 times. So this direction, we've cut it down by 1, so -1 in this direction. And so the first time we loop, it's going to look a lot like this, except for we're not even going to do the 0 comparison. We're going to skip it here and just go to 1. So 1, 2, and 3. So we started on 1 here. The next time we loop, we're going to start on the next one up. So we're going to go to 2. And then we're just going to go down from there. So this would be 2 and 3. And so instead of 2 here, now we're going to start with 3. And that would be the end of our loop. Okay, so we're going to have a nested for loop that goes from 16 times to now 1, 2, 3, 4, 5, 6. So now we have 6 times. We're doing each comparison from each object exactly once. We do all of the comparisons as well. So 0 is compared to 1, 2, and 3. But now we've already compared 0 to 1, 2, and 3, so we don't need to do any of that over here. Now we do 1 compared to 2 and 3. And then the only thing left is to compare 2 and 3 together. So that on the last loop, we just compare those 2 and we're done. And then 3 doesn't have to compare itself to anything, because if you look over here, 3 has already been compared to everything else in the array. So let's actually make a loop that does this instead of this. Back here inside our code, here is our nested for loop. We are actually going to start at 0. We want to end this way at the length -1, right? Because we don't want to do the last one. On this loop, we're going to start at 0, but we're going to go to the entities count -1. And then on the next loop, we want to start at whatever this value is +1. So whatever our first loop's starting point is, or whatever our first loop's value is, we want to add 1 to it. And you can see that happens each time. So here we're at 0, so the next one will be 1. Here we're at 1, so the next one's going to be 2. We just add 1 to it. And the next one, we're starting at 2, so we're just going to add 1 and get to 3. So back in our code, we're going to start at whatever our index is here, plus 1. So we'll be writing I plus 1. And then we want to end at the total count of the entity. So we want to go all the way to the last index in the entity count. And we can see that here. We go all the way down to 3, right? Each time we go down to 3. And so that's it for the for loop. Just by making that simple change, we start at 0 on the first one and then end at the count minus 1. And on the nested loop, we start at whatever I is plus 1 and then go all the way to the end of the entity count. And let's just go ahead and run this with the new code just to make sure it's working like we expect. We should be comparing every entity to every other entity exactly one time. It looks great. Looking at it, it looks like everything is working exactly like we left it before. It's just looping less times. We can probably even do a count. In fact, let's make a loop count just to see what the difference is. We have these loops back to the old way we're doing it, the less efficient way. I'm going to make a counter, which is I'm going to call loop counter, and this will be a temporary variable I'm going to set to 0. Down here, inside our update, here's where we start looping through the entities in our physics loop. I'm going to reset the loop counter to 0. And then here, every time we loop, I'm going to increment the loop counter. I want to be able to show what we are getting for the value of the loop counter. And so our flat asteroids project, I'm going to right click on that and go to properties. You have the output type here. Instead of a Windows application, I'm going to make this a console application. And all that does is it allows us to write things to the console. So the console will pop up first, and then we'll get our application, and we'll be able to put stuff in the console window like debugging information or anything we want, really. This can be changed back and forth, either between a Windows application or a console application, and it'll work just fine. Here, when we're getting keyboard inputs inside our update function, I'm going to ask the keyboard if the tilde key is down. If I press that, I want it to send to the console, or we're going to write line to the console what the loop counter has for a value. We have 31 asteroids, I think is what we defined. Yeah, so actually we have 30 asteroids, and then we also have the player class. So we have 31 entities total inside our list. And so this loop, we should be looping 31 times 31 times. So let's run that and just see if we get that value. There we are. So 961, that should be what 31 times 31 is. So if I take 31 and I square that, I get 961. Now let's go ahead and try the optimized version. So we set I starts at 0, but then it goes to the entity count minus 1. And then we start J at whatever I is plus 1, and then we go to the end of the entity count there. And let's see how many loops we have to do for this version. 465. So basically, did we cut that in half? Is that what that looks like? Let's go ahead and bring up the calculator here. So the first one was 31 times 31. So we were doing 961 loops, and now we're doing 465 loops. So let's divide that by 465 just to see what it is. Almost exactly in half. We're doing almost exactly half the number of loops that we were doing before. And actually, there's one more thing here. Now that we're doing it this way, we do not need to determine if I is equal to j, because it never will be based on the way we're doing it here. It'll never be that way. All right, so about a 2 times improvement in the number of calculations we have to do. Now, this is still a brute force method of doing the calculations. If we're going to have a lot of asteroids like this, we're going to start dividing the world up into pieces. For example, we could divide this into 4 pieces or 10 pieces, and then we'd have rectangles where each one of the objects would find themselves located, and they would only compare themselves to other entities inside those individual locations instead of comparing to every other entity. But for now, that looks good.